Okay. See, voltage in AC voltage always in terms of Vm cos omega t plus some theta. This is V, so you can say theta of voltage V. Okay, this is the AC voltage. AC voltage. Okay, and the similar way, current IT equal to Im cos omega t plus theta I. Okay, this is the AC current. Okay, power always multiplication of voltage and current. Okay, so the instantaneous power always voltage into current. So put the value here, voltage into current, Vm cos omega t plus theta V dot Im cos omega t plus theta I. Okay. Okay. Then you know one formula, that is cos A dot cos B equal A minus B plus cos A plus B. This is the formula of cos A dot cos B. So apply here. Here you can see that is this is your A and this is complete your B. Okay. Okay. So power PT equal to 1 by 2 Vm Im take cos omega t plus theta V minus omega t minus theta I, that is plus Vm Im cos omega t plus theta V plus omega t plus theta I, that is. So omega to cancel out. This will become 1 by 2 Vm Im cos theta V minus theta I plus 1 by 2 Vm Im cos 2 omega t plus theta V plus theta I. That is. So this power, this red box is represented for the constant power, that is constant, and this is your instantaneous power. Okay, what is mean by this? In the graph you can say, suppose we draw the PT power, then you get it like this. You know cos is started from the peak, but here is cos angle something detected, that is minus theta V. So the graph is started from back and going like this. Okay. Okay, this is time, and you know this is your some constant power. Okay, this one is constant, so you can say constant power, or this will is half Vm Im. This is the representation of any power, that is sum of some constant power and instantaneous power. Hello?
Yes, I
Hello?
am with you.
Okay. See, whenever I teach you, then you speak some after some time, so I can get it that you are hearing or not.
No worries, I can hear you. Yes.
Okay, then fine. Then I'll go for. If you have any doubt, then you can stop me and ask me any question. Okay?
Okay.
Okay. Okay. Now we have to find out the average power. Okay? Now we have to find out the average power. Average power. See, find out average of anything. Average of any data is always time interval and limit 0 to that time interval and the data, suppose some xt dt, average of xt. This is the formula of finding average of anything. Okay. So we find out average power, that is P. P is 1 by T.
Excuse me, your voice is lagging.
0 to T PT dt. Okay? Okay. Now you know what is PT. PT formula is PT. PT. Then you have 1 to V I theta V minus theta I plus 1 m I cos 2 plus, yeah. My voice is lagging. Hello.
Yes.
Okay. Now can you hear
Yeah,
me?
now it's better. Yeah.
Okay. If you another time my voice is lagging, then tell me. I'll change my Wi-Fi. Okay. Okay. So
Yeah.
I'm nothing doing. I'm putting the PT value here. That is, we derive constant power per instantaneous power. So I'm putting the value only. So I'll take terms and this term take common out. So this will become 1 by 2t. Okay. VMIM 0 to t cos theta v minus theta I dt plus 0 to t limit cos 2 omega t plus theta v plus theta I dt. Okay. Then you know that when we go for a solution of this integration, then may I solve or may I put the direct answer, which is you have to remember? Tell me. Hello. Okay. When we solve, then you get it Vm Im 2t. This will become cos theta v minus theta I. This will become t limit 0 to t. Okay. This will become 0. So Vm Im by 2t cos theta to t cancel out. Then average power P. P is 1 by 2 Vm Im cos theta V minus theta I. This way. Okay. Okay. Or you can say, see, any imaginary value. Okay. See, maximum value always root 2 times of VRMS. Okay, so that's why Im equal to root 2 times of IRMS. Remember this one also. So average power P is equal to 1 by 2 real part of VI conjugate. Okay. Why conjugate? Because here is angle is minus. Angle is minus theta I. That's why I am putting here conjugate. Oh, current. Okay. For resistance, or resistor, you know, voltage
Miss,
and current.
you are lagging a lot. I can't understand you. You like talk a bit and then you start lagging.
Okay, wait. I'm switching my network. Wait. Hello. 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 Hello, dear. Hello. Hello.
Still lagging.
Still lagging.
Yes.
Okay. Okay. Now for resistor voltage and current in phase. Sorry. Voltage and current in phase. In phase means there is no theta v minus theta I 0. Okay. So average power for resistor P equal to 1 by 2 Vm Im. Okay. 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 And as you know, theta v minus theta I equal to plus minus 90 degree. Then circuit has purely reactive load, means R, L or C, whatever. So power equal to 1 by 2 Vm Im cos 90 degree, that is 0. So P equal to 0 for reactive load. Okay. Okay. Means reactive load has no average power. Okay. This is your concept. Now we are going to solve the example. Example 1. VT. VT is given, that is 80 cos 10t plus 20 degree. And IT, current IT equal to 15 sin 10t minus 20. Okay. 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 Now we have to find out the instantaneous power and average power absorbed by the passive linear network. Okay. Here we have to solve the instantaneous power and the average power. Okay. Then answer. As you know that power always multiplication of current and voltage, whatever given. But remember one thing, that is this one is cos term, then you have to convert sine into cos, or both the same. Both have the same parameter, that is either cos or sine. Now I am going to convert current into cos term. Okay. Then 15 sine 10t minus 20. This one given. See, this is the sequence of converting. I'm giving you some concept, that is, here is sine theta, here is cos theta, minus sine theta, minus cos theta. This one is 90 degree. Okay, converting like this. If you convert sine some omega t plus minus theta, whatever, to sine cos term, then you have to come the same way, minus 90 degree. Okay, this one. So 15, this will become cos 90 degree plus something, whatever theta is given, that is minus whatever given, that is 10t minus 20. Okay, this will become 15 cos 70 minus 10t. Okay, minus minus plus means 110. 110. Okay. See, cos theta always equal to cos of minus theta. So I can write down here cos 10t minus 10. Because omega t terms we have to find out. Okay. If you have any doubt in this one, then you can ask me. Okay. Now power. Power, you know, 1 by 2 Vm Im cos theta V minus theta I. Okay. Okay. This is your average power. Average power. So this one is maximum value given, that is always maximum value. This one is Vm, this one is Im, this is theta V, and this is your theta I. Okay. Okay, I'm here putting the value 1 by 2, 80, 15, cos theta v is 20 minus of minus 110. Okay. This will become 1 by 2, 80 into 15 into cos 130 degree. When you solve this one, then you get answer like minus 350. Okay, average power. Now instantaneous power. Instantaneous power. Instantaneous power P equal to 1 by 2 Vm Im cos 2 omega t plus theta v plus theta I. Okay, I'm going to put the value here 1 by 2. This is 80, this is 50. Cos 2 omega t theta v plus theta I. Theta v is 20. This is minus 110. Okay, this will become your 600 cos 2 omega t minus 90 degree. Okay, this is your instantaneous power. Okay, this is your power, that is average power and instantaneous power. Now we go for the RMS value. What is RMS value? Okay, RMS value has another name, RMS value. Okay, RMS value also has another name, that is, or you can say effective value. Effective value. Okay, okay. So effective value is nothing. The formula is RMS. RMS means you have to put first square, then mean, then root. This is the step for doing any RMS value, finding any RMS value of any function. Okay, okay. So RMS value of any function like xt is given like xt RMS is given like square of that function, mean means mean, and by root. This is the sequence of doing RMS value. So here we have to find out the RMS value of power. So you know power is nothing but PT is current square T into R. Okay, okay. So power, we have to find out the RMS power. Okay, power RMS. So 1 by T, 0 to T. Okay, this one is your, put the value here, I square T R dt. This one is your average value, average power. This is your average power. Average power. And when you apply here RMS, current RMS value, that is current RMS value, apply this standard formula here, then you get it 1 by T, 0 to T, I T square dt and root. Means what is the step do you following here? That is first square, that is second is this mean, and third step is this. Okay, first for square, second for mean, and third one for root. This will become RMS. Okay, okay. So similar way you can find out the VRMS also. What is VRMS? Replace the current by voltage only. This is become VT square dt. Okay, this one. Okay. Okay. Then you know current I T is nothing but I maximum cos omega t. Suppose this one is your current. Okay, so put the value of it in the above formula. Put here in IT form in IT. So RMS value will become under root 1 by t 0 to t IT square dt. Put the value of IT in this one 1 by t 0 to t I maximum square cos square omega t dt. Okay, you know cos 2 theta equal to 2 cos square theta minus 1. Then this will become cos square theta equal to 1 plus cos 2 theta by 2. Okay, replace the theta by omega t. This will become I maximum square by t limit 0 to t 1 by 2 1 plus cos 2 omega t dt. When you solve this one, then you get it 1 by root 2 IRMS. Okay, this is I've already explained, already told you that is here. Okay, remember this star one. The star one is most important thing to remember. Okay, star one. Okay, star one is important things to remember. Okay, the similar way VRMS is also V maximum by root 2. Okay. So, as you know, power, average power, that is 1 by 2 Vm Im. We already derived this one. So, you can replace Vm by root 2 dot Im by root 2. I can write down like this only. So, this will become VRMS and this will become IRMS. Okay, or you can say VRMS square by R or IRMS square into R. These three are average power for resistance in terms of RMS value. Okay, and this will become average power in terms of maximum value. Okay, now I am going to explain you example number 2. Okay, so example number 2. The waveform is given, current waveform is given, and we have to calculate the average power for 9 ohm resistance. What is R is given, that is 9 ohm. Current waveform given, we have to find out the power. Power is asking. First, draw the waveform of current IT, T, triangular wave. This highest peak is 4, 0 to 2 time interval, 3. This one is given, okay? And IT waveform 4t when t is very 0 to 1, t vary 1 to 2, then this will become 8 minus 40. Okay. Answer. You already know that power is always equal to IRMS square into R, but you don't have the RMS value of current. That's why we have to calculate the RMS value of current. So IRMS equal to under root 1 by T, 0 to T, IT square dt. Okay. So here you know time interval T is equals to 2 here. So this will become 1 by 2, 0 to 2 IT square dt under root. So this will become 1 by 2, 0 to 1. What is 0 to 1? 40. Waveform is 40 square dt plus 1 to 2, 8 minus 40 square into dt. When you solve this one, then you get it 16 by 3 root. Okay? Okay. Or you have, if you can remember, then remember one thing that is here, that every triangular wave, highest peak is suppose A, then RMS value is always A by root 3, always, of triangular wave. Triangular wave have always RMS value is peak by root 3. Okay, this one is the IRMS. And you know, power is always IRMS square into R. That's why this will become 2.309 square. R is 9 given. To put the value here, 48 watt you get it. This is your answer for power. If a voltage RMS value is given, then voltage waveform is given, then we have to find out the RMS value of that voltage waveform, and VRMS square by R formula we use. Okay, depend upon the question, we apply the formula. Which data is given. Okay, now I'm going to explain you complex power. Complex power. Okay, what is complex power? Complex power is nothing but a combination of active power and reactive power both. Okay, and complex power is represented by the S. Hello? Hello?
Yes.
Hello?
Yes, yes.
Can you are you understanding or not my point?
Yeah, yeah.
Okay, then fine. Okay. When you speak in between the lecture, na, you can speak also.
Okay.
Complex power is represented by the S. Okay, and this is the 1 by 2 of I conjugate. That's why minus theta I. That is the concept. Okay. Okay. So I can write down V. This will become IM. So I can written I maximum by root 2 dot I maximum conjugate by root 2. So I can replace VRMS dot IRMS conjugate, that is as apparent power, you can say. Okay. Okay. So S is nothing but VRMS IRMS cos omega t is replaced by the theta v minus theta I. Why theta minus theta I? Because of conjugate. Okay. Okay. Okay, this is the angle. See, always any angle of theta can be represented by the cos theta plus iota sin theta. Okay, this is the concept. So S can be represented by VRMS, IRMS, cos theta V minus theta I plus iota sin theta V minus theta I. Okay. So S can be represented by VRMS, IRMS, cos theta V minus theta I plus iota VRMS, IRMS, sin theta V minus theta I. Okay. So this will is your P, that is active power, or real power. This is your reactive power, represented by the Q. This will P. Okay. So S equal to P plus JQ. Okay. Always remember, this one is your complex power, and P is, you can say, IRMS square into R, and Q is IRMS into X. X is your reactive. X can be XL or XC. What is XL and what is XC? XL is omega L, that is reactive inductance. Yeah, reactive inductance. This will become 2 pi FL. And reactive capacitance XC equal to 1 by omega C or 1 by 2 pi FC, where L equal to inductance, C is capacitance. Depends upon the data. Okay. Okay. So finally, you can say real power or active power, that is represented by the P. P equal to VRMS, IRMS, cos theta. This when that complete red box is important. VRMS cos theta and reactive power represented by the Q, VRMS, IRMS, sine theta. Okay, where in the both formulas theta is nothing but theta v minus theta I. For angle difference between voltage and current wave. Okay, and the complex power is a complex power equal to S, that is P plus JQ, and the apparent power nothing but this is the vector sum. So magnitude of vector is apparent power is P square plus Q square root is your apparent power. Okay. Okay. Now time is unit. What is the unit? Power. P has unit watt. Q has unit bar. And S has unit volt ampere. That is the unit of apparent power, real power, or reactive power. That is. Okay. If you have any doubt till now in my concept, then you can ask me any question. Okay. Do you have any doubt?
No, nothing.
Okay. 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 Tell me, do you need extra example or you are only need your PDF example? If you need extra some extra numerical or extra example, then I'll go for that one also. Tell me.
Whatever you think is best.
What is it?
Whatever you think is best.
Okay, whatever I think. Okay. Okay, then I'll go for the extra example. Whenever I need, then you have to understand. Okay. 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 See, always. What is, how can you understand what is real power, what is reactive power, what is apparent power? Then I'll go for some basic life example. That is, suppose here is some source. Okay, voltage source VT, and here is some electric motor. Okay, so source give to motor is active power, and motor give to that source, that is reactive power. Okay, and this all combination is reactive power. Okay, All give concept is apparent power. Apparent power. Okay. Now okay. Now that next slide in your PDF, that is not important for understanding the power system or power electronic concept. That's why I'm skipping that slide. Okay. Okay. See. L and C has active power P equal to 0. Remember this one. Okay. Okay, series parallel combination given active. Okay. Next slide. Suppose is parallel combination parallel combination is given here. That is, there is voltage source plus minus V is given. There is some Z1 impedance Z2. Do you understand what is Z1 and what is Z2? What is Z? Do you know about anything? Z. Tell me. Do you know anything about Z? What is Z? Tell me. Hello.
Yes.
Okay. Tell me what is Z?
What is what?
What is Z? Z impedance. What is impedance? Do you know? Okay. If you don't know, then tell me. I'll explain you.
Yeah, I don't know.
You don't know. Okay. Okay. See. From A to basic one. What is impedance? Okay. See. R is your resistance. Unit is ohm. L is your inductance. Unit is Henry. Okay. C is capacitance. Faraday is unit. Okay. So then again, this one is the representation of resistance. This one is the representation of inductance, and this is the representation of capacitance. When we connected inductor and resistance in series, this one is R, this one is L. Then Z equal to, Z is impedance. Unit is ohm. So Z equal to here for this one, R plus J XL. What is XL here? I already told you XL is omega L, that is 2 pi L FL. Okay, the unit is here also ohm. This one is the impedance for this circuit. If resistance and capacitance will become like this, capacitance and Z will become R minus JXC. Okay, what is XC? XC is 1 by omega C. 1 by 2 pi FC. Unit is ohm. Remember this one. Always remember these are the impedances for any series circuit. If parallel combination is given, then this will become some different. So impedance is nothing but combination of resistance, inductor and capacitance given according to the circuit, that is vary according to the circuit. What is Z? Okay. Here you have to remember that is what is XL? This one. What is XC? That is you have to remember. Okay. And what is the unit of R, L, C, XL, XC and ZA are all has the same unit, that is good. Okay.
هنجيب المخافض.
What is it? Hello. Okay. So are you asking something? Your call has been. Hello.
Yes.
Are you asking?
No, I'm not.
Okay. Here parallel combination is given of Z. Okay. Do you know anything about the parallel series combination?
Yes.
Okay, then fine. So here is voltage plus V is given. Here is impedance Z1 and another is Z2 in parallel combination. Okay, as you know that is parallel combination. That's why different current flow I2, I1, and that is current I. Okay. Okay. So you know power S equal to 1 by 2 VI conjugate. Okay, so 1 by 2, two load, first load this one, second of this one. So V I1 conjugate, I1 plus I2, I equal to here I1 plus I2 conjugate. So this will become 1 by 2 V I1 conjugate plus 1 by 2 V I2 conjugate. So this will become S1 plus S2 as equal to. Okay. Whatever is given parallel series combination, you can apply this concept. Okay. Now I'm going to explain an example. Okay. We have to find out here total complex power of 3 load. We have to calculate it. Total complex power. We have to calculate it. Where is current I flow? Load first is given. Here is load 2. Here is load 3. Okay. Load 1 is 0 watt and 100 volt. Means resistance this one. This one is 100 watts. That is for L and 20 volt. 200 volt is given. This one is 1 150 watt for capacitance. This one is 300 watt. Okay, and here is voltage applied, that is E, 100 watt angle 0. Okay. Okay. So we have to calculate it for total complex power. So you know for load 1 Q1 is equal to 0, Q2 equal to 700 and Q3 equal to minus 150, because capacitance reactive power always take negative capacitance. That's why here negative for capacitance. Okay. So Q total, tell me Q total. Q1 plus Q2 plus Q3. So 0 is 700 minus 1500, that will become minus 800 watt. Okay. P1 is 100 watt. P2 is 200 watt. See, P1, P2, P3, all three power is given. So this will become total power P1 plus P2 plus P3. P1 value is 100 watt, P2 is 200 watt, and P3 is 300 watt. So this will become 600 watt PT. As you know, complex or apparent power S equal to P plus JQ. Yeah. So ST is equals to PT plus JQT. Put the value of PT is 600 minus J800 ST. Okay. If you have to find out, this one is your answer. If you convert it in the angle form, then how can you convert? ST equal to ST mod angle of ST. Okay. Remember one thing, x plus iota y can be represented by, suppose this one is your z, whatever is data, modulus of z angle of z. So mod of z is equals to under root of x square plus y square. And how can you find out theta? Suppose this one is theta. Theta equal to tan inverse imaginary value by real value. This will, you have to convert in the phasor. So ST will become 600 square plus 800 square under root, and angle will become tan inverse minus 800 by 600. So this will become 1000 angle minus 15.13. This one also right answer, and this one is also right. You can put whatever you want to do. Okay? Okay. Now I'm going to explain the next example. Total complex power of 3 loads given. We have to find out what is total complex power. We have to calculate it. 3 loads is given. First load 1 given, that is this one. And this one is 800 kilowatt minus 6 kilowatt. And this one is your 10 kVA. Angle is minus 36.87. Okay, load 2 is given. Three loads is given. Okay, three loads. Okay, not three loads, only two loads given, not three loads. Okay, only two loads given, not three. Second load is this one, 20 kVA. You can say this one is your P1, this one is your Q1, or this one is your S1. This one is your S2, this one is your P1, 12 kilowatt. This one is your Q1, that is 16 kVAR. And angle is 53.13 angle. This one is given. Okay. So we have to calculate the S, total S. Okay, and phasor diagram you can draw. S total equal to, you know, P total plus J Q total. P total is what is? P1 plus P2. Okay. So P1 is 8 kilo plus P2 is 12 kilo. So this will become 20 kilowatt. Same way, Qt equal to Q1 plus Q2. What is Q1? Minus 6K plus Q2 is 16K. So this will become 10K VAR. Okay. So as total is, put the value 20 kilo plus J 10 kilo. This one is your answer. When you converted in as total, then this will become 20 square plus 10 square under root. Angle is 10 inverse 10 by 20. So this will become 22.36. Angle is 26.56 angle. So you can represent like this: 20 kilowatt, that is P total. Q total equal to 10 kVAR, and S total equal to 22.36 kVA, and this is your angle 26.56. This is your example number 5. Okay, now go for the example number 5. Reactive load is given. Okay, this one is the very simplest one. Question: voltage source is given, VT, that is 100 volt. RMS value given. This one is your resistance, 100 ohm, and IT current flow, and IRMS value is 1 ohm given. Okay, and we have to find out the complex power. Okay, complex power. So as you know, complex power for resistance, for resistance or resistor, S equal to VRMS IRMS. Okay, VRMS value 100 volt given. This one is given. IRMS is also given 1 ampere. This will become 100 VA. Okay, and you know here reactive power for R is always 0, and S equal to P always. This one is your resistor. Now we go for the inductive load. This one is here you can explain one thing, that is example number 6. I'm going to explain you what is active, reactive and load. Okay, voltage source V, here is resistance, here is inductor. Resistance is 50 ohm, inductor is 86.6 ohm given, and you know here is current flow IT. Okay, and given data VRMS value is given, that is 100 volt. IRMS is 1 ampere given. Okay, okay. Now we have to calculate the complex power here. So complex power. What is complex power? P. First we have to calculate the real power, then I'll go for the reactive power. Okay? Okay. Let's see. Real power P equal to IRMS square by R 1 by 50. You can say J Q equal to IRMS square by XL. This one is your XL because unit is ohm. And you can clearly see this one is reactive inductance. Reactive inductance. Okay. 1 by 86.6. Or you can say S equal to VRMS IRMS. That is 100 VA. Okay. Okay. So here is a reactive inductance. That's why Q is come in the figure. If only resistance, then Q is not in the figure. Okay. Okay. Now one another important is come in the picture, that is power factor. Power factor. What is power factor? Power factor. Power factor is real power by apparent power. Okay, means power cos theta. Power factor is cos theta. Okay, this red box you have to remember. Till now, if you have any doubt, then you can ask me. Hello? Hello? Hello?
Yes, yes.
Do you have any doubt?
No, just you can continue.
If you have any little bit doubt, then you can ask me.
Yeah.
Okay?
Yes.
Okay, because if you are not speaking with me or communicate with me, then I'll not understanding you are getting my point or not. That's why I'm asking again and again. Are you getting? Are you getting?
Yeah, I'm writing notes. It's okay.
Okay.
Yeah.
Since you are understanding what are I'm trying to tell you or what are I'm trying to teach you.
Yep.
Okay, then Roshan. Okay, these are the basic concept of power: active power, apparent power, average power, RMS power, reactive power, complex power. Okay, then I'll go for the power factor. Okay. If you have different type of currents, okay, suppose I1, I2, oh sorry, suppose if current is given like that, current I, that is I not DC value, Im sin omega t plus I2 sin 2 omega t, like that. Okay, then RMS value of current IRMS equal to I naught square plus 1 by 2 I1 square plus I2 square, and so on. Okay. This one is the way of finding different type of concept. Sine and cos term is addition of something. That is the harmonic component. Okay. Okay. Hmm. Okay. So you can say, in according to your book, according to your PDF, IRMS equal to I naught. I naught is nothing but DC value. I DC square plus I RMS of first square plus I RMS of second square, and so on, where I DC equal to DC component of current or average value of current. I RMS first means RMS value of fundamental component. I RMS 2 RMS value of and harmonic component. Okay. Okay. So any current, if represented, if sin IT equal to, suppose given like that, sine omega t plus theta plus sine 2 omega t plus theta 2 theta 1 like this plus sine 3 omega t plus theta 3 so on. So how can you combine these terms? Summation n equal to 0 to infinity sine n omega t plus theta n. Okay. Okay. Now we have to calculate the instantaneous power. You know, always time period here you assuming because of sine time period t is 2 pi. Okay. So this will become 1 by 2 pi limit 0 to 2 pi pt dt. Okay. pt is nothing but dt into it. Okay. So p equal to 1 by 2 pi limit 0 to 2 pi. V is Vm sine omega t. Put the value of I and is I maximum sine and omega t plus theta n dt. Okay. Okay. When you solve this one, then you get one answer that is VRMS IRMS cos theta 1 means fundamental RMS value 1 fundamental RMS value. These are the power, fundamental power. Now I'm going to explain you what is the power factor. Power factor represented by the PF. Short form of power factor is PF. Okay. I already told you power factor is nothing but real power by apparent power. Okay. The real power value VRMS, IRMS, cos theta 1. Okay. And you know apparent power is nothing but VRMS, IRMS. Okay. This is the power factor of 1 means fundamental RMS value. This will become IRMS. Yes. Okay. So power factor VRMS and IRMS cancel out. This will become IRMS value of fundamental 1 for fundamental, n equal to 1 means fundamental. Plus theta 1 by IRMS. Okay. Okay. So power factor will become distortion factor multiply by the displacement factor. Hello. 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 Hello.
Yes, yes, hi.
Can you hear me?
Yeah, I can hear you. Hello?
Yeah. Listen, I'll come within 2 minutes because my iPad is getting discharged. Okay. Wait
No,
for 1 minute.
no problem.
No problem. Wait for 2 minutes. Hello.
Yeah.
Yeah. See, this one is the displacement factor and distortion factor. What is displacement factor or distortion factor? Distortion factor. Distortion factor. Okay. Distortion factor is always less than 1. Okay. And what is mean by that distortion factor? It is utilization of source is reduced due to harmonic current. What is displacement factor? Okay, is always less than 1. it is utilization is reduced due to phase shift between voltage and fundamental current. Okay. Okay. So here is some table is given. Okay. Okay. Power factor. Means three type of load you as you know. One is R. Okay. One is L or C. Another is R plus L or C, whatever is given. Okay. Three types of combination where theta V minus theta I is equal to 0 because in resistance, voltage and current in phase always. Okay. When inductor or capacitance, whatever, theta V minus theta I plus minus 90 degree. Okay. When R and means Z is given, then theta V minus theta I is greater than 0 or maybe theta V minus theta I is less than 0. Okay. So here is power factor is 1. For resistance, power factor is 1 always. For resistance, remember, for resistance, power factor is 1 always. Okay. Means is resistance consumed, active power consumed. Active power consumed. Consumed. Okay. Here is power factor equal to 0. So no real power consumed. Means P equal to 0 here. Okay. If here is a lagging power factor, power factor is lagging for inductive loads means R plus some L given, and power factor is leading for capacitive load means R plus some C is given. This is, and what is mean by that? Here power factor always less than 1. Okay. Means some part of apparent power is assumed. Some part of apparent power is consumed. Okay. This one is your concept of power factor, distortion factor, displacement factor, but most important factor is power factor, that is represented by the cos theta. Okay. Okay. Here is some triangle. One is power triangle impedance triangle. Okay. If Q, that is reactive power, Q is positive, means power factor lagging. Means inductive load. Means R plus some JXL in the figure. Okay. When Q is negative, then power factor is leading. Is capacitive. Okay. Again, because of the lacking my iPad, some part of it is, so I'm explaining you the last one page. If Q is reactive power, Q is positive, means power factor lagging, means load is inductive nature. Is R plus JX. First condition. Second, Q is negative, means power factor is leading, means node is capacity, means R minus JXC like that given. Okay. So now I'm going to explain you power triangle. As I explained you in previous one example, that is P power, Q power, S, and this is theta. Okay. So here is PS equal to P plus JQ. Okay. Okay. And this is your power triangle, impedance triangle. This is R X, or this one is XL or XC, whatever, depends upon the data, theta, and this is the modulus of J. So always remember one thing, that is Q equal to 0 for resistive load, means only resistance is given, that is resistive load. So power factor is unity 1. When Q is negative, means Q is less than 0, means capacitive load. So power factor is leading. When Q is positive, means Q is greater than 0. So inductive load, means power factor is lagging. Okay. These are your week 2 PDF, that is upon the power load only. This is PDF is your own power: apparent power, active power, complex power, power factor, and that's all. If you have in this PDF or this week 2 concept any doubt means any doubt, so you can ask me. Do you have any doubt? Hello? Hello? Are you there?
Yeah, I'm here.
Do you have any doubt till now?
No, so understand.
Understand?
Yeah.
Okay. Means your week 2 PDF is completed. If you want speed slow, then I'll go for slow. If you want speed fast, then I'll go for fast. Or if you think this speed is sufficient, or then you can tell me. Tell me. This speed
No.
is fine.
Yeah, it's good. It's good.
It's good or fast.
No, good.
Good. Okay. Then I'll go for the week 2 losses and harmonics. Okay.
Okay. Can we do that one for tomorrow if possible?
What is it?
The harmonic. Let's do it tomorrow.
Tomorrow.
Yeah, tomorrow.
Why? Today is you remaining your 10 minutes only in your
Sorry?
time. You have some 10 minutes in your lecture.
I know, but I would like to finish it tomorrow altogether, like start and finish.
Okay, wait for 2 minutes. I'm talking to Mr. Agarwal.
Okay, sure.
I'm going to explain you one example, then I'll leave you. I'll leave you. Okay,
Okay.
and some extra example. Okay. See, example. If R equal to 3 ohm and XL equal to 4 ohm given, then find Z and Q and P when VRMS is given. This is 100 ohm. Okay, then you know connected in series. Means this is resistance, inductor. This one is given and this is your voltage source. VRMS equal to 100 volt. R is 3 ohm. XL equal to 4 given. Then you know Z equal to series, that's why R plus JXL. Z equal to put the value of R3 plus 4J. This one is your Z impedance. Okay. And we have to find out the power P. VRMS. Okay. Or here you can say IRMS square into R. Then VRMS equal to 100 volt. So IRMS is nothing but VRMS by mod of Z. Modulus of Z. 100 by modulus of Z. Mod of Z is nothing but 3 square plus 4 square, that is 5. So IRMS is 100 by 5, that is 20 ampere. So active power P equal to IRMS square into R. IRMS is 20 square into R is 3. So 120 reactive power Q. Q you know is IRMS square into XL. 20 square into 4. So 1600 watts. If asked apparent power or complex power as P plus JQ. Why plus? Because Q is positive for inductive load. Okay, that's why S equal to 1200 plus J 1600 volt ampere. This is your complex power. If apparent power ask, then find the mode of that. This will become under root of 1200 square plus 1600 square. Okay, then you get whatever you answer, get it, that is your answer. Okay, this is the example of inductive reactance, impedance, active power, reactive power, and complex power series combination is given. Okay, now if you have any doubt in this example, then you can ask me, otherwise you can leave the class. Okay, hello. Hello.
Oh yeah.
Do you want PDF of my this class? Do you want?
Yes. I would appreciate. Yeah.
Okay, then I'll send you the PDF. Okay.
Okay.
If you want, then you can leave the class.
Okay. Thank you.
Thank
Thank
you.
you.
Bye. Good night.